Morning, everyone. Good afternoon, everyone. Good afternoon, everyone. Good afternoon. Yesterday, we have started with the basic exercise of chapter number 12. So that basic exercise was not over, and still one question is left, question number 4, which is an important question. So we'll start with this question after a minute. Okay, then we are starting with this solution. The wheels of a car are of diameter 80 centimeter each. Okay. The wheel of a car is of diameter 80 centimeter each. How many complete revolutions does each wheel make in 10 minutes when the car is traveling at speed of 66 km per hour? Okay, let us write all the given things. Radius of wheel, that is 80 by 2, 40 centimeter. And it is asking that how many revolutions does each wheel make in 10 minutes if the speed of the car is 66 km per hour. Let us write here speed, which is given. Speed is 66 km per hour. Okay, then 66 km per hour. Now this is in centimeter and this is in minute. I am converting it into meter per minute. Okay, so 66 multiplied by 1000, this will get converted into meters, and 1 hour multiplied by 60, it will get converted into minutes. Cancels out, this and this cancels out, so this is 1100 meter per minute. This is the speed of the car in meters per minute. Now time given here is 10 minutes. So let us calculate how much distance will be traveled by the car, will be covered by the car. So distance is equal to speed into time, where speed is 1100 and time is 10, which is 11,000 meters. Okay, now we will think on how the wheel and the distance are related to each other. See, suppose it is a wheel. As the wheel revolves, it will cover a certain distance. Suppose after one revolution, the wheel will reach this point. Okay, then after one more revolution, uh, then it will reach this point. So after each and every revolution, it will cover a certain distance. Okay, so these revolutions are depend on the circumference of the wheel, because the perimeter of the wheel will be in contact with the, means boundary of the wheel will be in contact with the surface. So therefore, let us calculate here circumference of wheel. And before calculating circumference, let us write again radius. Radius is given in centimeters. Let us convert it into meters. Zero 0.4 meters. Now, circumference of wheel is equals to distance covered by wheel in one revolution. What do you mean by circumference of the wheel? It means how much distance in one revolution the wheel will cover. That is 2 pi r. That is 2 into 22 by 7 multiplied by r, which is 0 0.4. Last it is 17.6 by 7 meters. So this much distance will be covered by wheel in one revolution. Now, number of revolutions, if you want to calculate, then it is total distance covered upon distance covered in one revolution. Total distance divided by distance covered in one revolution. So total distance covered is 11,000 upon distance covered in one. So let us divide it by distance covered in one revolution. 11,000 into 7 by 17.6. Remove the point and cut by 11. It is 1,000 and it is 16. Now it is 10,000 into 7 upon 16. With 16 we can cut this. 625, and 625 multiplied by 7, that is 4375 revolutions. Note it down. This is the complete solution. Note it down. Now, after this, we'll start with the main concept of this chapter. This is just the recap or the revision. Okay, I'll repeat this question. See, radius of the wheel is given 40 centimeter and speed and time is given. Speed is given in kilometer per hour. First of all, you need to change this speed into meter per minute. Why in meter per minute? Because this we can convert into meter. and this is in R. And just see this. This is in centimeter. So we can convert this in meter as we have converted here. See this. Radius is converted into meter. So this also we have converted into meter to make the unit same. Okay, and hour is converted into 1 hour is converted into minutes. So multiplied by 60 minutes. Why? Because in question they are talking about time in minute. So that's why first of all the first step is to convert speed into meter per minute. After this, the time is also in minutes, so we can multiply speed and time to calculate distance. So how much distance the car will travel? 11,000 meters will be traveled by a car. If the car is traveling 11,000 meter, it means a wheel also is covering 11,000 meter distance. So wheel is covering 11,000 meter. Now listen to me one thing. Wheel covers 11,000 meters in how many revolutions? They are asking in how many revolution will it cover this much distance? So that we don't know in how many revolution, but we can calculate in one revolution how much distance it can cover. In one revolution, the wheel can cover the distance equal to circumference of wheel that we have calculated. Circumference of wheel is equal to distance covered by wheel in one revolution. Yes. And because of this, we know that 17.6 by 7 meter is the distance which wheel has covered in one revolution. Okay, now total distance is 11,000 and in one revolution, the distance is 17.6. So we can divide the both to take out number of revolutions. Total distance divided by distance in one revolution. Then you will be able to know how many times the wheel rotates or okay to complete this distance. 4375 is the answer. Starting with the discussion of the formulas for the next exercise now. You need to write the formulas now in your notebooks. Put the heading on new page. We have written the basic formulas related to circle. Now, write quadrant. So area of quadrant. First of all, you should know what is quadrant. A circle with 4 equal divisions. Now this circle is divided into 4 equal parts. And these 4 equal parts are divided in this way that here there is a making of 90-degree each. You can make this figure for your understanding of quadrants. These all angles are 90-degree at the center. This is the center of the circle and these all are making 90. If the circle is divided into 4 parts with an angle of 90-degree, it means all the 4 parts are equal and these all 4 are quadrants. Quadrants means a quarter. Quarter means 1/4 of anything. So 1/4 of the circle is known as quadrant. So area of quadrant is 1/4 of the area of circle. Note it down. Area of circle we know, and quadrant we know that this is the 1/4 part. So 1/4 into area of circle. In the same way, circumference or length of arc. See, if I'm talking about this quadrant, let me color it, this green colored quadrant. If I'm talking about this, then what will be the length of this arc from here to here? See, we know that length of this full arc is circumference of circle, and this is just 1/4 part of the circle. So we can say here that length of arc in quadrant is, or circumference of the quadrant is 1/4 of 1/4 of the circumference of circle. So this is pi r upon 2. Okay, so let us talk about next sector. Make the figures also okay. Here we have a center. Let this be theta. O A B. Now sector, you should know that this is the area between area bounded by two radii and arc. First of all, you should know what is sector. Area bounded by two radii and arc. This is sector. So if I'm talking about these two radii and this arc AB and the area between these two radii and arc, this is known as minor sector. What we say it? This sector is divided into two parts. First, minor sector. So what will be the area of minor sector? That is, see, the area of circle is pi r square. See, all the formulas are derived with the help of area of circle and circumference of circle. Area of circle, full area of the circle is pi r square, but area of this part of the circle, how we can calculate? What is the angle here? Here it can be any angle. I have assumed that, as we don't know what is the angle here, so I have written here theta. Okay, so what is the full angle here? That is 360 degree. And this is just theta out of the full angle of 360 degrees. So we'll write here a fraction pi r square multiply by theta upon 360 degree. So this is area of minor sector. Pi r square into theta upon 360, area of minor sector. And area of major sector, so you can write here, we are talking about area. Area of minor sector. Now in the second part, area of major sector, that is pi r square into, now for major sector, no, you need to see this white portion is major sector, this is minor sector, and this is major. And if you will see, this is also between the radii and the major arc. The area between the radii and major arc is major sector, and for major sector we need this angle. the this reflex angle. Okay, this is the angle for the minor sector and this is the angle for the major sector. So this angle we can calculate by subtracting theta from 360 degree. So 360 minus theta upon 360. This is the area of major sector. Sector is over. Now next is segment. Keep on writing these formulas. Discussion of these formulas are very important because with the help of these formulas only the full chapter is based on the rest of the chapter. Now what is segment? Area between chord and arc. So this is an area this green colored area is the minor segment and this white one portion is major segment, and let here be the center and join from the center to here and join from here also, and here exists an angle theta, this also. So this green color portion is minor segment and this full white color portion is major segment, including this also area, this full white. Okay, this is all major segment. So how to calculate the area of minor segment? Area of this formula is not given in NCERT for minor segment, but you can solve with this with the help of this formula. Easy to solve with this. R square pi theta upon 360 minus 1 upon 2 sine theta. This is minor segment. Okay, now sine theta, yeah, trigonometry is included. Then area of major segment. For major segment, you have to calculate minor segment, then you can subtract from area of circle. So area of circle minus area of minor segment. Okay, so this is for major segment. It means for major segment, you have to find the area of circle, then area of minor segment, then subtract both. Then so till now, now we have discussed quadrant, then sector. See, quadrant is also a sector, and in quadrant the angle is 90, and so we have made these formulas. Here sector, there can be any angle. If here the angle will be 90, it will become a quadrant, or it angle can be 30, 60, 90. Okay, 45. These will only come. Okay, then segment. After this, the next. So we have discussed so far. We have discussed sector also and segments also. Now what is left? Length of arc. If you want to calculate length of any arc of a circle, suppose I want to calculate length of this arc AB. Let me make this figure again here. See, if I want to calculate the length of this arc AB from A to B here, okay, then how? See, a length of the full arc means full circle is the circumference of the circle, that is 2 pi r. So 2 pi r is circumference of circle, but we have to only calculate the length of AB from A to B, this arc. Then we need this angle, that is theta, and the total angle is 360. So circumference of the circle into theta by 360 is length of any arc. You can calculate. Clear? Let us start now. The exercise. Note it down. So starting with the exercise. Exercise 12.2. Question number 1. Find the area. No, Pranshu, today it is only one lecture today. We have of mathematics, no 2 lectures. So find the area of sector of circle with radius 6. Radius of circle is given 6 centimeter, and theta means angle of the sector is given 60. What do you mean by this? There is a circle and they're talking about a sector. This is a minor sector because the angle is 60 degree. So that's why it is minor sector. If angle will be more than 180 degree, it will become a major sector. Simple, no? See this. If an angle is 60 or less than 180, then it will a minor sector. If an angle will become 180 degree, it will become a semicircle. And if angle will become more than 180 degree, it will become then a major sector. These are the basic things which you might have done in 9th also. Okay, in this case, you can make a figure to make you understand where is the sector. This is 60 degree and this is the sector. Okay, so area of sector, use the formula of minor sector because angle is less than 180 degree. So area of minor sector is equals to pi r square, area of circle, multiplied by theta by 360. So pi 22 by 7 into r, 6 into 6 into theta 60 upon 360. 6 and 6 cancels out. So the answer is 132 by 7 centimeter square. That's it. Over. Moving on to the next question. Question number 2. Find the area of quadrant of a circle whose circumference is 22. So circumference is given and we need to find the area of quadrant. So from circumference, first of all, we should calculate the radius. we have to find the area of quadrant of a circle, and circle's circumference is 22. So circumference of circle is 22 centimeter, and it is 2 into 22 by 7, and it is 2 pi r. It's 22, and r is equal to 22 upon 2 pi, or make it simple, put the value of pi here. 2 into 22 by 7 into r is equal to 22, where r is equal to 22 into 7 upon 2 into 22. 22 cancels out, so it is 7 by 2 centimeter. So r we got 7 by 2 centimeter. Now we can find the area of quadrant. Since area of quadrant, I have told you that angle is 90 degree. If you want to use the direct formula which we have written, you can use that. Pi r square by 4. Suppose you forgot the formula, then how will you calculate the area of quadrant? Then you should know that area of quadrant include angle 90 degree. Okay, if somehow if you have not, if you don't know this formula, then you can apply the formula of area of minor sector, that is pi r square into theta by 360. Then pi r square into theta. Theta here is 90, means angle here is always 19 quadrant. So this is, see this, it is same. Pi r square into 1 by 4, pi r square into 1 by 4. Okay, so that's why 1 by 4 into pi 22 by 7 into r square. So we can write 2 times 7 by 2 into 7 by 2. 2 and this cancels out, 7 and 7 cancels out. So it is 77 by 8 centimeter square. Note it down. Let us do the next question. The next, third. The length of a minute hand of a clock is 14 centimeter. Let me make, first of all, a clock. 12, 3, 6, 9. Now see, the length of the minute hand of the clock is 14 centimeter. Okay. And there exists a shorthand also. Okay. Now the length of this hand is 14, and find the area swept by minute hand in 5 minutes. Now they are asking how much area will be covered by the minute hand in 5 minutes. After 5 minutes, this minute hand will move from here to I hope it is clear. Now minute hand, from here to here it will move, and this much is the angle which is made by this, and how much area is covered by the minute hand. See, this will become a sector. How much area is covered by minute hand? This much area. This is the area which is covered by minute hand in 5 minutes. But how you will calculate this? We don't know even the angle here. So the 5 minute which they are talking about, with the help of this we can calculate the angle. So theta here is equals to 5 minutes divided by total, that is 60. See, 5 minutes divided by 60 multiply by 360 degree. So 30-degree angle will be made by minute hand if a minute hand will cover 5 minutes. Is it clear? See, 5 minutes is from 12 to 1, but from 12 to 12 it is 60 minutes. So what is the fraction? 5 upon 60 minutes. Multiply it by 360 degree, because 60 minutes is also equals to 360 degree if we are talking in degrees. Because in 60 minutes also a complete angle will be made, that is equal to 360. So we can convert this into degrees. The minute can be converted into degrees. So theta is 30 degree, and length of minute hand will be considered as the radius, and radius here is the length of minute hand. That is 14 centimeter. Then area swept by minute hand in 5 minutes is equals to pi r square into theta by 360 degree, where pi is 22 by 7 and r is 14 into 14 into theta is 30 upon 360. This being 12 and 7 2s and 2 6 2 3 2 7 154 by 3. This much area is swept by minute hand in 5 minutes. Note it down. Rest of the questions we'll do tomorrow. Lecture ends here only. You can try the next question even by your own with the help of formulas. This the first 7 questions are based on 7. The question number 7 is not in your syllabus this year, as 120-degree angle is not in your syllabus. This is cut. So one question is cut from this exercise. That is question number 7. If you want to do that question, you can do. As angle is given 120 degree, I'll tell you one thing, that sine 120 degree is equal to sine 60 degree. If sine 60 is root 3 by 2, then sine 120 will also be root 3 by 2. Okay, this concept is used there. But 120 is out of syllabus this year from boards. Okay. So according to CBSE, we'll do 1 to 6, then 8 to 14. Okay, bye.